Hi there everybody, welcome to our vodcast on earthquakes. Now this is the second video in our earthquake series. The first one we talked about how earthquakes actually happen and their relationship with the plate boundaries on Earth. But this one we're going to talk about the origin of the earthquakes and the types of waves or seismic waves that are released when an earthquake happens. So let's get started. Okay, so in the first video we talked about how when tectonic plates move, they get stuck, and as a result they build up stress, and eventually they reach an elastic limit, they exceed that limit, and then they break and they move, and when the plates slip and move, they return to their original shape and release seismic energy. Now the seismic energy is in the form of seismic waves. Now, when we take a look and find out where earthquakes occur, there's actually two spots that we can reference. One spot is called the focus. The focus of the earthquake is actually the location under the Earth's surface where the seismic energy is being released and where the plates move. So if you take a look at the diagram here, you'll notice that the focus is down here way below the surface along the fault line. And in our last video, we talked about strike slip, normal, and reverse faults. However, when you hear about earthquakes being reported, you'll hear people refer to the epicenter. They'll say the epicenter was in Loma Prieta, California for the 1989 earthquake. So the epicenter refers to basically the location on the Earth's surface directly above. So if we take a look at this diagram here, the focus again is down below the Earth's surface on the fault line, but when we go straight up above it to the Earth's surface, that's where we have our epicenter. So remember, the focus is the actual point in which the seismic energy is released under the Earth's surface, and the epicenter is the location above the focus on the Earth's surface. Now, when this earthquake happens, the damage is done by seismic energy called seismic waves. So let's take a look at what those waves are. So there are three specific types of waves which get grouped into two groups, which we'll talk about in a little bit. So the three specific types of waves that we have are called primary waves, secondary waves, and surface waves. Now these waves are different in their properties and how they move and how fast they move and so forth. So let's start with primary waves. Now, primary waves are also known as P waves. The P stands for primary. And the primary waves are going to be your fastest waves that travel through the Earth. So what happens is, well, when an earthquake releases seismic energy, the first type of waves that are going to hit an area are the primary waves. And the primary waves, if you take a look at this diagram here, they kind of spring back and forth. So it's as if you pulled some of the coils of a slinky back, and then you let it go, and then the coils bounce back and forth. And this is what this motion looks like in action. Now here we have an animation of primary wave or P wave motion. And if you take a look at the P waves are just going to spring back and forth. There's no up and down movement. There's no side to side movement. It's just back and forth movement. And because of this compressional force or this compressional movement, this allows the wave to travel the fastest because it's going in a straight line, as opposed to the other waves which move a little bit differently. So that's how a P wave moves. The next thing you need to know about primary waves is that they can travel through any state of matter. So when these waves travel through the Earth, they can travel through solids and the liquids of the Earth, and also gases. Primary waves, fastest seismic wave, that's why they're called primary, because they are the first or primary waves on the scene, and they can travel through solids, liquids, and gases. S waves are a little bit different. S waves are the secondary waves, so that's why they're called S waves, for secondary. And if you think about the name kind of tells it all. The secondary waves are the second waves to hit the scene, so they're the second fastest seismic wave. And the reason why they are the second fastest seismic wave is because they have a little bit more space to cover when they move in motion. Okay, so if you've ever taken a slinky or a hose or even like a bed sheet and you just gave it a big quick snap, you'll notice that a roll or a fold just flies right through those things. And that's what an S wave is. So this S-shaped curve travels, goes back and forth along this path. So this energy has to go left to right and left to right in order for it to move. Whereas the primary wave energy has to just go back and forth. And this is what an S wave looks like. So here we have an animation of an S wave. And as you can see, the S wave tends to move from side to side. All right, so the energy has to go left to right and left to right. And since it's going left to right, it's going to take longer to travel through the Earth because there's more distance to cover. So that's the difference in the motion between an S wave and a primary wave. Now, the other thing that's really actually special about the secondary waves is that they don't travel through all states of matter. So what happens is when secondary waves travel, they can travel through solids and gases, but they cannot travel through liquids. And this is actually pretty important in discovering that liquid is actually inside the Earth. And we'll talk about that in a little bit. All right, and then lastly, we have the big waves, the waves that do all the damage. And these are called the surface waves. The surface waves are going to be the slowest waves. So they are the last waves on the scene. Despite the fact that they're the last waves on the scene, they're the most damaging or most violent waves on the scene. Because if you take a look at the picture here, the surface waves not only make the ground snake back and forth or left to right if you were standing and facing one way, but it actually rolls the ground too. Almost like ocean waves in the ocean. So these telephone poles would start to move up and down on the ground like a buoy floating in the ocean. So the surface waves are what are going to cause the most amount of damage because they are actually moving the ground that things are attached to. So these are three types of seismic waves that get released. The primary waves, the fastest waves, move through solids, liquids, and gases. Secondary waves are second fastest waves, which can travel through solids and gases but not liquids. And then the berserkers of them all, the surface waves, which are the slowest seismic waves that do the most damage. Now, even though we have these three specific types of waves, they're actually grouped into two categories. So let's take a look at them. Okay, so when we talk about seismic waves, we have two groups. We have the body waves and we have the surface waves. The body waves are the waves that actually travel through the Earth. So they travel through the body of the Earth. So if we take a look at the picture here, you'll notice that the black arrows are the P waves or primary waves, and the red arrows are the secondary waves. And you'll notice that these waves travel through the middle of the Earth. So the P waves travel all the way through, as you can see. They go from the crust down through the mantle, through the liquid outer core, and then into the inner core, which is solid, dense metal, and back out through the liquid outer core, and back through the rocky mantle, and so forth to the other end of the Earth. And the reason why we know that there's liquid in the middle of the Earth is because, as we said before, S waves cannot travel through. So when these earthquakes release S waves, different earthquake centers that have seismographs that record this energy will come up with seismograms, the drawings of these earthquakes, at certain spots, but on the opposite half of the Earth, they won't get those secondary waves. And the reason being is because when the secondary waves hit the outer core, which is liquid, they stop. And that's how scientists know that the inside of the Earth has some sort of liquid layer in it. Okay, and when we talk about our body waves, we always refer to our primary waves, the P waves, and our S waves. Those are the body waves that travel through the body of the Earth. Now let's take a look at an animation that shows the travel of body waves through the Earth. Now here's the Earth, and at the focus, the seismic energy has been released. So you have your P and your S waves traveling through the body of the Earth, the green being the S and the purple being the P waves. As you can see, based on the properties of these waves, your primary waves travel through the entire body, solids and liquids, of the Earth. However, your S waves do not. They get blocked by the core, and as a result, because of the densities of the materials and the fact that there's liquid in the middle, some of these waves do not actually reach certain areas of the Earth, and these are actually called your shadow zones. Okay, so that's what body waves look like, traveling through the Earth. So that covers our body waves. Now the last group of waves are the same exact waves that we talked about before. They are our surface waves. And surface waves only travel along the Earth's surface. They can travel for long distances, but unlike body waves, they're not going to travel all the way around the Earth. And this is what a surface wave looks like when it rolls through an area. Okay, so in this animation, we have our focus releasing seismic energy going throughout the Earth. So here are our body waves and seismic waves traveling away from the focus of the earthquake. Now, when the surface waves travel through the ground, they cause the ground to start moving and rolling, as you can see here. So you can have the rolling of the ground like ocean waves, like we said before, and then also the movement from left to right of the ground. So that type of movement is really going to knock down any type of structure there is. And that's what a surface wave looks like as it rolls through an area. And that concludes our vodcast for tonight on earthquakes, their origins, and their seismic waves. Thank you for your time. I hope you found that helpful.